Since factoring can be kind of a hard concept to grasp initially, here's some more examples for just general factoring. So my first example here is 3x squared plus 3x plus 3. We can see that they all have a common 3. Therefore, the 3 can be factored out if we want to. Now, as we can see here, I just went ahead and pulled out the 3, and each of these was just whatever was left without the 3. And again, to check that, make sure we did it correctly, we can multiply it back out, go 3 times x squared, 3 times x, and 3 times 1. Now, I also want to point out here that when we factor out the 3 from this here, this 3 by itself, it doesn't become 0, it must become 1, so that when we multiply it 3 times 1, we get our 3 back. If we just pulled it out and assumed it was 0, it would disappear and it would no longer be the same as the original. Now, there's also something funny about this problem that I'd like to point out that could potentially be confusing. It looks like, remember when we talked about our specific case, where it has this general format, and then we do this specific process for this specific case? Well, this one does look like that. However, I want you to note that there is a number in front of the x squared, which can make the process that we talked about for this specific case difficult. It changes it, and it just makes your algebra hard. So, it is generally a good idea to try to get rid of this number out front, if you can, and in this case, factoring out the 3 was a good way to do it. As you can see, now we've got the 3 out front, and we have this stuff all separated out without a number directly in front of it. We could deal with what's in the parentheses separately if we needed to. So in this case, it was good to get rid of that front number anyway. Alright, second example. Right here we can see that we have x squared plus x. Remember, if we want to factor, we have to find what they have in common. We can see that both of these terms have at least one x. And again, let me say that terms are basically the things in between the plus or minus signs. So here we have one term, two term. So what do they have in common? At least one x. As you can see that I wrote in green there. So I pulled out an x out front, put the parentheses, and filled in what was left in the middle. So when we pull an x out of x squared, what's left? Well, we had two x's here. We took away one, pulled it out front, so now we had the one left. Now, with this x, we pulled out the x out front, and what do we have left? Just a 1. Why do we have to have a 1 left and not a 0? Because when we multiply this out, x times x, and x times 1, as you can see I wrote it here, xx plus 1x, then I rewrote it x squared plus x. It has to go back to the thing, to the original problem. If it does, when you multiply it back out, if it doesn't look like the original, you did something wrong. Probably forgot to write a 1 somewhere. Alright, let's look at this next one. See, this one, they both have at least 2 x's. This one has 4, this one has 2. We can't pull out any more than the minimum, or else we will mess our whole thing up. But they both have at least 2 x's, so we can pull out those 2 x's out front. And what do we have left here? Well, we had 2 left from the first term, and we had no x's left, but we just had that 1 left from the second term. And again, to check, x squared times x squared, and x squared times 1, so you see I wrote that out here, equals x to the 4th plus x squared, which is what we had in the original, therefore we did it right. Next problem. We have x cubed plus x squared plus 5. Now, in this case, you know, notice that some have x's, but not all. Well, we can factor from just these first two terms. It's not really a great situation, but there's nothing wrong with it. It just doesn't always help us, but I'll show you how to do that anyhow in case it could help you. So, we'll notice between these two that they both have at least two x's. So we did the same process. I pulled out the x squared out front. There was 1x left from the x cubed, and there was a 1 left from the x squared. And then this 5 didn't have an x, so it didn't get included in the parentheses, and it also didn't go away. It's just sitting there by itself. We didn't touch it, we didn't do anything with it, so we just continue to write it. Now, if we want to check ourselves, x squared times x squared times 1, plus 5. So x squared times x here, x squared times 1, then the plus 5 is still there. If we write it back out, we get x cubed plus x squared plus 5, which is the same that we had in the beginning. Same as what we had. Therefore, this factoring was okay. Mathematically sound. I want to point out that this is what we call incomplete factoring. It is incomplete because not everything is included in a set of parentheses. This 5 got left out here, versus what we were doing before. This is not in a parentheses, but it's touching a parentheses, and that's good enough. And then both these things are inside parentheses. Both these things are inside parentheses. This is touching parentheses. So basically, everything needs to be either inside a set of parentheses or touching parentheses in order to be considered complete factoring, as in the case of these two problems. Alright, so with this one, I just wanted to point out that you can also factor out things that have negative signs. So we have 5x minus 5, which is kind of like one we did a while back. But in this case, we had a negative 1 left here. So 5 times x, 5 times negative 1 would be the negative 5. Don't forget about the negative 1 right here, so that you get your negative 5 back and not a positive 5, because that would be bad. Now in this case, you can see that both the x and the 3 are negative. Now in some cases, having a negative x is annoying. Having a negative anything can be annoying in certain math problems. So what I did here was I factored out a negative 1. It's basically just a mathematical trick to make the negatives go away. It doesn't make it entirely go away, it just sort of pushes it under the rug for us. So how I did that was I factored out a negative 1, pulled out that, because you can see that negative x is the same thing as negative 1 times x, and negative 3 would be the same thing as negative 1 times 3. So therefore, if I say negative 1, parentheses, x plus 3, we have negative 1 times x, negative 1 times 3, they wrote out here, and we would get our negative x minus 3, which is the original. So this is okay, that is fine to do, and you can see that we have positive x and a positive 3, which can be nice in some cases. And our last example, I wanted to point out that you can not only factor out an x or a number, you can factor out an x and a number. You can factor out anything they have in common. So in this case, we have 6 times x squared minus 3x. 6x squared minus 3x. Now we can see that they both have at least one x. So 1x can be factored out. However, they also both have a number up front. This is a 6, this is a 3. It's not the same number, however, 3 is a factor of 6. In other words, there are things that multiply up to 6 that include a 3. So, to put that plainly, for example, 2 times 3 is 6. And because you can say something times 3, something times whatever, and there's a 3 is one of them, to equal 6. 2 times 3 is 6. Therefore, 3 is a factor of 6. but perhaps will be more clear if you look at this right here. So I pulled out a 3x. That was the largest number I could pull out because that's the largest number I have here. But 3x times 2x, 3 times 2 is 6, x times x is x squared. As you can see, I wrote 3x times 2x, so that goes back to 6x squared, so that one's okay. And then 3x times negative 1, don't forget your negative because you need to bring that back, but we couldn't bring it out here because this one didn't have a negative. 3x times negative 1, I wrote here, equals negative 3x. So again, if you want to check yourself, just multiply it back out and see if you get the original. In this case, we did get the original, therefore this is an okay thing to factor. And again, you can factor out numbers and letters at the same time. Whatever you can do, just check yourself with multiplication, and you should be okay.